Hello and welcome to the third of our videos preparing you for your GCSE summer exams. Now, continuing on from yesterday's video, we're again going to look at the angles topic, and we're going to look at some new principles, new techniques on these angle questions and bits of information that you need to know. Now, looking at the video from yesterday, a couple of you have already spotted that I mentioned that this angle here was angle ABD, but as some of you correctly spotted with my deliberate mistake, that angle there should be CBD. Now we may slip in some of these little techniques, because if you are able to spot the errors, that shows you have a really good understanding of the topics. Now we're going to blast through some of the techniques and some of the key information that you need to know, and we're going to get one of our special guests in to talk through some of the exam questions again. So one of the other things you need to know with angles is to be able to identify and use a bit of angle knowledge. Now, alternate angles can be identified, and alternate angles are equal when we have these things called parallel lines. Now, parallel lines are often identified by these little arrows, and we can tell alternate angles by looking for a Z shape. So if ever we see a Z shape, then we know that this angle here is equal to this angle here because they are alternate angles. Now you can't just say because it's a Z shape, you have to use this word alternate. Now the next thing we can look at is angles called corresponding angles. Now corresponding angles are also equal and they require parallel lines. So we can identify corresponding angles with an F shape. They're in the crook of the F. So this angle here is equal to this angle here. So there's an F shape. F is corresponding angle. Now, also, we know that allied angles add up to 180. So again, if we have a pair of parallel lines, and we have a line that cuts through them, these angles here, for example in this case X and Y, add up to 180. So if I were told, for example, that Y is 110, I would know that X is 70 degrees because allied angles add up to 180. Now the last bit of information on this topic is about types of triangles. Now an equilateral triangle has 3 equal sides, so 3 equal angles. An isosceles triangle has 2 equal sides and 2 equal angles at the base. And a scalene triangle has 3 unequal sides and 3 unequal angles. And again, it's important to know that the angles in a triangle add up to 180 degrees. Now we're going to use this information to answer a few questions now. So we're going to get my friend Ross on board to answer a couple of these questions. So Ross, can you use the information then? Can you work out the size of angle marked X and give me a reason for this, please?
Yeah, well basically you get the 126, and because there's 180 on a straight line, you take 126 from 180 and that should give you your angle on the inside.
So 180 minus 126, what's that then, Ross?
That is 108. Oh, sorry, 54.
Okay, so we got 54 is this angle here, okay? Now, obviously, this gives me this angle here, but I'm trying to work out angle X, Ross. So what would I do next?
Well, you can tell by the marks on the side of the triangle that this is an isosceles triangle.
Okay.
So the bottom two angles are exactly the same.
Brilliant. So what's this angle here then?
54.
Okay, what's the next step then?
Well, we all know that 180 is in a triangle. So you need to add the two sides up.
So I do 54 plus 54.
That would be 108.
Yep.
And then you take it away from 180.
Okay.
Which gives you 72.
So my answer for angle X that I would write very clearly is X equals 72. What does this little symbol here mean, Ross?
Degrees.
Brilliant. Excellent. Great knowledge. Now moving on to our next question then. I'm going to get you to do this one as well, Ross. You can prove to me that you've been listening. Okay, so go down to our next question. Okay, on this question then, Ross, we're looking for AB is parallel to line CD. Now this time what they've done is they've put the parallel lines facing up, but that doesn't matter, they still have the same effect. So the question is, write down the value of x and give me a reason for my answer. So what's my answer then, Ross?
Well, x would be the same as angle A because it's corresponding angles. So it'd be 123.
Okay, so we're looking for this angle here, 123 degrees, is the same as this angle here, 123 degrees, and it's what's my reason again, Ross?
Because they're corresponding angles.
Okay, corresponding. And what shape am I looking for?
You're looking for an F shape.
Excellent, and I can draw that in with the red pen there. Okay, Ross, final question for today then. AC and DG are parallel lines, so can you point out those lines for me?
A and D to G.
Okay, so AC and DG are the parallel lines, okay? So explain then to me, Ross, why angle BEF is 40 degrees. First of all, though, can you point out angle BEF to me?
Just that, yeah.
Okay, so that angle is angle BEF.
Yeah.
Okay then, Ross, so why would you say that angle BEF is 40 degrees?
Because it is an alternate angle.
Okay, so it is an alternate angle. And what shape are we looking for there then, Ross?
A Z shape.
Excellent, so we can see the Z shape on the parallel lines.
Yep.
Excellent. So I know then, Ross, that that angle there is 40 degrees. Okay, so we're going to mark that in there. So the next part asks you to show, giving reasons, that triangle BEF is isosceles. So how am I going to do that, Ross?
Again, you got a straight line.
Okay.
So you know it's 110 on the outside.
Yep.
So you take 110 from 180 to give
Okay.
you the inside angle.
Okay, and what would that be then?
70.
Excellent. What's my next step?
Well, to find out the degrees in a triangle is 180.
Okay.
So you add the 40 to the 70.
Okay, so 40 plus 70.
Then once you get your total, you'll take that from 180.
So 40 plus 70 is?
110.
Excellent, 110 degrees. So I take that from my 180 degrees.
Will leave you with 70.
It leaves me 70 degrees. So this angle here is going to be?
70.
Excellent. So I have to show, what's my reason then that BEF is an isosceles triangle?
Because in a isosceles triangle, two angles are equal.
Okay, so the inside of an isosceles triangle, two of the angles are equal in size. So this angle is 70 and this angle here is 70, and therefore we've proved that is an isosceles triangle. But obviously we'd write that down in the bottom here as well. Ross, you've been a star, outstanding. We're going to leave our viewers with one more question that they can try themselves, and they can bring the answer or they can tweet me the answer, and obviously any topics they want to cover as well. Tweet at PCSA Maths. Ross, you're a star. Cheers.
Thank you.